The webinar itself is roughly about 17 minutes, and if you have any questions at any point, feel free to put them into the chat. We'll get going.
Welcome to today's tutorial. Let's get started. So let's have a look at today's agenda. As you know, we're going to be looking at compare functions. We'll begin by looking at traditional compare functions, including the limit function. Then we will look at time and date compare functions. We will also have some application examples as well as a video demonstration. As always, we'll finish with a Q&A session. Today, we're talking about compare functions. This starts with the traditional compare functions, such as the less than, greater than, etc. We also have some other functions that you may not be as familiar with, including the limit function, which is great for determining if processes are in alarm or running normally. We also have the time and date compare functions. If you are doing any scheduling with your machine, these function blocks can save a lot of work. There will also be many examples and demonstrations of using these functions in the coming slides. So let's start with standard compare functions. Compare functions in Cscape, just like any other ladder editor, provide the ability to be able to compare the values of multiple variables, or a variable against a constant. These are the traditional compare functions of equal, not equal, less than, greater than, etc. In addition to this function, under the compare group, the project toolbox, you've also got the limit function. With traditional compare functions, we start with two inputs to the function block. Then we have two variables that could be compared against each other, or you could compare one variable against a constant. And if they're true, they're going to pass power flow. One tip that you may not be aware of is, let's say that you're in the middle of programming and you've inserted the incorrect compare function. You don't have to delete that and put a new instruction in. You can simply right-click on the existing compare function and then change to a different compare without doing any reprogramming and without entering in the variables again. While you're likely familiar with the traditional compare functions, not as many people are familiar with the limit function that's also included in Cscape. With the limit function, instead of having two inputs, you have three. You have the variable that's going to be compared, then you have a low input, which is your lower limit, and a high input, which is your higher limit. If the variable is between the low and high inputs, then the function block passes power flow. This is useful for determining if a process is running normally. So, if you've established a low limit and an upper limit, and the current variable is between them, the function block passes power flow, and you know that the system is running normally. For example, let's say that for the low input of the limit function, we have a value of 25. And for the high input, we have a value of 75, and our variable is 15. Our variable is below the low input, therefore the function is false, so we're not going to pass power flow. If the value of our variable is 50, we're in between the limits, therefore the function block is true, and we pass power flow. Then, if the value is 80, we're going to be above our higher limit, therefore the function block is false. The limit function is also useful to detect an alarm condition. For this, you reverse your low and high inputs. So, the upper limit you put as the low input, and the lower limit you put as the high input. Then, when you do your variable comparison, if the value is not between those two limits, then the function block passes power flow. Looking at our example, this time my low input is 75, while my high input is 25. We pass power flow for the values of 15 and 80, which are outside our limits, triggering our alarm condition. Then we don't pass power flow for a value of 50, which is a normal condition. Now let's look at time and date compare functions. These are useful for when you are trying to schedule something to occur at certain times of the day, certain days of the week, certain days of the month, etc. You can always use traditional compare function blocks and take advantage of the system registers that contain all the real-time clock information. You see those listed there on the right. However, if you do take advantage of these time and day compare functions, In many cases, you get some extra functionality or faster implementation that you wouldn't get just by using traditional compare function blocks and having to use multiple compares. Let's start with the time of day compare function. This is a function block that passes power flow if the current time of day from the OCS real-time clock falls in between a start and an end point that are entered into the function block as either variables or constants. If the current time of day is in between the start time and the end time, then this function block is going to pass power flow. Notice that variables are handled as integers with a separate integer for hour and a separate integer for minute. With the time of day compares, you're likely going to assign variables as the input to the function block instead of hard coding a particular time. That's because you may wish to change your start and end time in the future without using Cscape. For the day of the week compare, it might make more sense to hard code it in, because most of the time you know if you want something that occurs during the work week, Monday through Friday. For this, you simply select the radio button for each day of the week that applies. You can also assign a variable to the day of week compare instead. For this, the input is a single integer, where each day of the week is bitmapped to a particular bit, with Sunday starting at the least significant bit and then moving up the days of the week all the way through bit 7. Next, let's look at the day of the month compare. Let's say you have something that occurs on a machine twice a month, and for example it's always on the 15th and the 31st. You can represent this with a double integer. Here, the least significant bit is the first day of the month, and the 31st bit of that 32-bit double integer is the last day of the month. Then you can set a 1 for the days that you want to have power flow passed on the function. Next, we've got the month of the year compare. Here, the 12 months in the year can all fit easily within a single integer. January is bit 1, all the way up through December, which is bit 12. The top 4 bits are all going to be zeros. So if you want something to occur only June, July and August, then you can set the June, July and August bits to 1s, and then use this function to compare the current time and date in the calendar clock. Next, there is the year compare function. With this, you can set that if it's between 2 assigned years that you want to pass power flow. This function is probably not as applicable compared to the others, however it's very straightforward. You simply have a start year and an end year, which are consecutive integers. Now, let's talk about applications where you can use these time and date compare functions. Lighting control is one good example. These functions could be used for turning the lights on and off, changing their intensity or color, etc. at certain times of the day. Production monitoring is another good example. In many cases, we want to get data out of our machines to see how efficiently we are using them, among other factors. Scheduling is important in this regard. Another use is preventative maintenance. You could use these compare functions for scheduling certain days of the week or month when you may want maintenance to be done on your machines to prevent future issues. Now, let's begin our demo, where we'll be looking at using these functions together with realistic examples, including a HVAC system and a lighting control system. First, we will look at how we can use traditional compare functions. Here we have an application for scheduling maintenance of air filters of a machine in a HVAC system. Here, the air filters of this machine need to be changed twice a month. We also have logic here, which is checking to see if today is the date of the month that we have assigned to have the filter changed. Let's look at how we would program that. So I'm going to go to my View Edit screens. Then I will navigate to the relevant screen. Here you can see I have 2 variables. The first variable is filter change day 1, which is an integer representing the day of the month. Then we have a second date we want to have a filter changed. And make sure you have the correct variable assigned, which is filter change day 2 in this case. Now we have 2 different dates on which we can get a light to turn on and notify us or maintenance staff that we need to change the filter. Now we'll go back to the logic. Here we are checking if the current time and date is equal to the first filter change day. Then we are checking if the current time and date is equal to the second filter change day. And if either one of those is true, then we're going to turn on a pilot light flagging us that we need to change the filter. Next, if it's neither of the assigned change days, we are going to clear our filter flag. Once again, make sure you have the correct variable assigned here, so we have filter change day 1 and filter change day 2. This is a good example of using compare functions for preventative maintenance. Next, we're going to look at the limit function. This function is looking at air pressure, which is shown on the right hand part of the HMI screen, along with my low and high limits. In this function, we've set a low limit and a high limit for our differential air pressure. If the differential air pressure falls in between the low and high limits, the air pressure is normal, and if it falls outside of that, the normal coil will not be turned on because we will not be passing power flow. In the next function block, we've reversed the high and low input. The high level is set for the low input, and the low level is set for the high input. This means that if the variable falls to the low limit or below, or rises to the high limit or above, the function block is true, triggering our alarm condition. If we look at our current air pressure on our HMI screen, which is 0.75, then you will see that we're in between our limits and in the normal range. If we were to change the high alarm level to 0.6 instead of 0.8, you can see that we're now in alarm because we're no longer between the normal limits, and our alarm condition is triggered. Next, we're going to be looking at examples of time and date compare functions, such as the time of day, day of week, and day of month compare functions. This time we are going to be using an example of scheduling lighting control. First, let's go to the main menu on my OCS, and then I'm going to go to my facility lighting page. Then I'm going to open the relevant section of the ladder. This is the lighting control. Here we have logic that detects if it's a weekday or a weekend, and based on that, we're going to be setting a different schedule for turning the lights on and off. First, we're going to look at our start and stop times on the HMI screen. I have set the start and stop times for my weekday lighting control, my weekend lighting control, and my holiday lighting control. Let's look at how we would do that in Cscape. Here you can see the time objects being used, where you point at a variable and you can then use this block to display the current time, display a set time, to change a set time point, etc. For this function block, you assign a variable which is an integer with a dimension of 3, which when you're talking about time is seconds, minutes, and then hours. So the first word is seconds, the second word is minutes, and the third word is hours. Here we have the weekday start time variable assigned to this object, which is an integer type variable with a dimension of 3. I have selected hours and minutes as my display format. Double clicking again here, I've also made it editable, meaning I can change it from the touchscreen on my HMI. For example, if I do that now, you can see I can change my time set point from 6:12 to a time of my choice. Let's say 6:06. Again, that is the object I've used on the HMI screen to display my start and end times for the weekday, the weekend, and the holiday. Now let's go back to our logic and see how that applies. What we are looking at when talking about weekdays is this function block, whose start hour and start minute point at the data object I just showed. Note, I'm only involving minutes and hours here, and not seconds. So that's how I can use the time of day compare block to check if the current time falls between the start and end times I want for lighting control on a weekday. In combination with this, I've also got this day of week compare. In this case, I did not assign a variable, and instead hard-coded Monday through Friday as the input to compare. So overall, this compare function will pass PowerFlow if it's not a holiday and if the current day from the real-time clock is somewhere between Monday through Friday. If it is, I check to see if our time falls in between my turn on and turn off point for my lighting control. If it does, I set a coil that says I want the lights on. For weekends, I'm instead just checking to see if it's Saturday or Sunday, and then checking to see if we're falling between the set on and off times I assigned for the weekend. And then I set a coil that says I want to turn the lights on if that is the case. To show how I've implemented holidays, I'm going to look more closely at the HMI. Then I'm going to open the set annual holidays function. What I've programmed into the OCS is a way to quickly enter all the holidays for the year or add a new one if a new holiday comes up. On the left, you have the 12 months of the year, and on the right, you have 31 days. So, for example, I'm going to enter in some holidays for the month of January. January 1st is New Year's Day. And let's just do another day, the 18th for instance. Once I've selected those, I hit Set Holiday. Going back to Cscape, I'm using this day of month compare function where the input is a double integer that contains a bitmap of this month's holidays. We are in February where there are no set holidays, so when we execute this compare, it's not going to pass PowerFlow, and therefore Cscape will determine that today is not a holiday. For the days that it is a holiday, then it's going to use the time of day compare that was configured on the start time and end time screen that we showed a few minutes ago, and use the start and end times we set for holidays. To wrap up, this is a useful way of creating scheduling in your OCS, or for doing anything where you need to detect a certain time of the day, certain day of the week, day of the month, etc. Thank you for joining today's tutorial, and the Q&A session will begin shortly.
Okay, nice and straightforward one this morning. Looks to be anyway, there's no questions in as yet. I shall take you to the screen and show you what's coming up as always. So you should hopefully be seeing my screen right about now. So we have our list of upcoming webinars. We did our compare functions just there now. Next week we do have part 3 to IEC support. And followed up by high-speed outputs using trends and data parsing instructions. The registrations are all there for those, so if any of you wish to be involved in those, you can just register now and you'll get reminded just before the time. And as always, if there's anything you ever want to look back on at any point, they are all in the past section. And if there's something you haven't seen in the past section or that's not in the upcoming, feel free to drop us a mail if there's a topic you want covered, and we will try to get that done for you as well. One more check of the questions panel. Not seeing anything. Thank you for joining us this morning, and I hope to see you again next week.